Good morning and welcome to a walkthrough on 2017 AP Chemistry question number 4. Number 4 starts by saying a student investigates various dyes using paper chromatography. The student has samples of 3 pure dyes labeled A, B, and C, and on a sample that contains one of the 3 dyes. The student prepares the chromatography chambers shown above on the left by putting a drop of each dye on the indicated position. On the chromatography paper, a polar material, setting the paper in a non-polar solvent. So this is non-polar, the paper itself is polar. The developed chromatograms are shown on the right. A, which dye, A, B, or C, is the least polar? Justifies your answer in terms of the interaction between the dyes and the solvent or between the dyes and the paper. So, there's a lot going on here, but let's start by breaking it down. We are asking which dye is the least polar, or to rephrase it, which dye is the most non-polar. And we only have 3 options. Now, because this is a polar piece of paper and a non-polar solvent moving across it, we can know that non-polar substances will move more and polar substances will move less. This is because like attracts like, or like dissolves like is how you typically hear it, but like attracts like. Which that means is that the polar paper will be more attractive, more attached to polar molecules, and thus they won't move as far because they're closer stuck to the paper, as opposed to the solvent, which is nonpolar, which is moving up the sheet. The more nonpolar substances will move farther. So if we look at the developed chromatogram, B moved the least distance. That tells us B is the most polar. A is somewhere in the middle, and C, which moved the farthest, is the most nonpolar because it moved the farthest with the nonpolar substance. So, with that said, you need to be able to choose and justify to get both the points available for this question. So dye C is the least polar because it moved the farthest, would get you 1 point. And then nonpolar dyes are more strongly attracted to the nonpolar solvent, would be a way to justify it. Or nonpolar dyes are least strongly retained by the polar paper. Either works. Whatever it is, whatever you choose, remember with chromatography, it's like moves with like. So if you have a non-polar solvent, the one that moves the farthest is non-polar. If you had a polar solvent, the one that is most polar will move. It's whatever is moving will match whatever moves the farthest. Non-polar, non-polar, polar, polar. B then asks which dye is represented in the unknown sample. Justify your answer. With chromatography, you always want to refer to RF. The RF, or retardation factor, is a measure of how restricted the motion of the dye is. It's always a ratio of how far did the dye go versus how far did the solvent go. So if we look at this, in this particular image, B moved about 1/3 or 1/4 of the entire distance. A moved about half. C moved about 3/4 of the distance between here and here. If we go over to the other one and look at our unknown, it didn't go quite as far, but we need to look at the relative amount of distance it went. Its eyeball it estimate looks to be about halfway. So the retardation factor here is about a half, and the only one that has the same RF factor over here is A. So A is the unknown because it moved a similar percentage or similar fraction of the distance the solvent did. Or more appropriately, the unknown is dye A because the RF factor is the closest. And that is 2017 AP Chemistry question 4. Thanks for watching.